Today we are going to be learning about two things that may happen when you are solving equations with variables on both sides. If you haven't already, please set up this green practice page. Hit pause while you do that, and please label, just like this example, two special cases. Please record our first example, letter A. I'm going to begin by making my lines down the equal sign, and I'm going to think about my flip book. The first page of my flip book asks to look for parentheses to see if we need to do the distributive property. I don't see any parentheses on the left side, and I don't see any parentheses on the right side. I'm going to flip and skip that page of my flip book. The next page asks me if I have any like terms to combine on the left side or on the right side of my equal sign. I am shaping right now, and I notice that on the left side I have two ovals or two x numbers that I can combine. I've got positive 1x, I know there's an invisible 1 that I can write in if I need it, plus negative 6x. Positive 1 plus negative 6 is negative 5x. The negatives won that battle because they had 5 more players. I also have a plus 4 that I'm just going to bring down because there is nothing I can combine him with. On the right side, I have two plain numbers that I can add or combine. I have positive 6 and negative 2. 6 positives and 2 negatives are positive 4. I also have a minus 5x, which I'll bring down. Now, I've combined like terms, so I'm going to flip the page of my flip book and notice that the next step is to cancel the variables on one side of the equal sign. I am going to cancel negative 5x on the left, and I do that with a positive 5x. I'm going to put a positive 5x on the other side as well. I've canceled my variables on the left, and on the right I'm going to do some calculations. But I notice that I've got 5 negative x's and 5 positive x's. That also cancels. That makes 0 just like this side, and it also cancels. What I've got left is a positive 4 on the left and a positive 4 on the right. This special situation is called an identity. It's not as important that you know it's an identity, but what's really important is that you know what the final answer for this problem is. If you get a statement that is true, it is true that 4 is equal to 4, then your final answer is infinite solutions. What that means is you could put any number in the place of x, and this equation will work. We could substitute negative 2.5, we could substitute positive 5, anything will work. Your final answer is that there are infinite solutions. There is one more case where your final answer is not going to be a single number, but it's going to be some words. I have to begin the same way I did last time by taking a look at each side of my equal sign. If I look on the left side, there are no parentheses, And there are no parentheses on the right either. On the left, I'm going to start shaping, putting ovals around my x numbers and rectangles around my plain numbers. On the left side, I notice that I have two ovals, two x numbers that can be added together. I have -8 and +9. In this battle, the positives win, but they only win by 1. They only brought one more player, so I have 1x. I also have a +6. On the right side, I only have one oval and one rectangle, and I cannot add an oval to a rectangle. So I'm just going to recopy that side to simplify. All right, now I'm going to flip the page of my flipbook and notice that I have to cancel the variables on one side. This time I'm going to cancel on the right side, and the first thing I'm going to do is remind myself that I've got an invisible 1 there. So to cancel out a positive 1x, I'm going to subtract 1x. I've canceled out my x's on the left, but just like last time, I'm also going to end up canceling my x's on the left. 1 minus 1 is 0. A positive 1x and a negative 1x cancel one another. What I have left is 6 equals -17. This is just like the last problem, except that what I have here is an untrue statement. It is not true that 6 is equal to -17. This situation is called a contradiction. And your final answer is going to be no solution. What that means is that there is no number that we could put in the place of x and have this equation work out. Those are two special cases that you may run into when you're solving equations. So there are 3 options of answers that you may get. Just like we have been doing so far, you may get a number answer. If you get a number answer, you will end up with something like x equals -2. That is a number answer that we have had for the past few weeks. You may end up with a true statement. A true statement would be something like 5 is equal to 5. If that's the case, your final answer is infinite solutions. Infinite, remember, means infinity, forever. There are millions of solutions to that problem. The third thing that could happen when you get an answer is that you get an untrue statement. An untrue statement is something like -3 equals -7. That is not true. In fact, we can use the not true equal sign over here. And your final answer for that is no solution. Go ahead and try the 6 problems from your homework and see if you find a combination of number answers, true statements, and untrue statements.